Hi there and welcome to our final lesson in our final chemistry topic C6, Chemistry Out There. And today's lesson is all about detergents. Now today's lesson is also a little bit of revision of some of the stuff we did back in C1, all about emulsifiers, where we have very similar reactivity and very similar keywords that we had back in that topic. To do with water loving and water hating, hydrophilic and hydrophobic. Anyway, I hope you enjoy this and I'll see you at the end. Okay, so let's have a look at our objectives for this lesson on detergents. So by the end of this lesson you should know and understand the chemical properties of detergents and how they are able to clean. Now, washing powders are a mixture of different cleaning components. These include a detergent to do the cleaning, a bleach to remove coloured stains, a water softener to soften any hard water, an optical brightener which will make clothes appear whiter, and then finally enzymes to remove any food and protein. Now with washing powders you end up forming a solution. Now a solution contains three parts, a solvent and a solute, and then you have your overall solution. Now in the case of washing powder, the solvent is the water and the solute is the washing powder, and then overall you get that solution that is made. Now in order to do washing up you normally use a low temperature. Now the low temperature allows you to protect delicate fabrics that could shrink if you used hot water. It also stops dyes from running. The low temperatures also allow the enzymes to work so that you don't denature those enzymes, and then it also allows you to save money on your electricity and energy bills. Now similar to washing powders, washing up liquids are also designed to remove stains. Now they have a slightly different makeup to the washing powders. Again, they contain a detergent to do the cleaning. They will also contain water that will dissolve the detergent and also dilute the detergent so it's able to pour out of the bottle. They contain a water softener, again to soften hard water. They also contain a rinse agent that will help water to drain off things like crockery and cutlery. And then finally, to make the washing up liquid seem desirable, they also put colour and fragrance into it. Now you may also need to have a look at some data, which we've got an example of some here, that might evaluate the effectiveness of washing up liquids. So you've got three different washing up liquids. You've then got how many plates they washed and the cost for that particular washing up liquid. So which one may offer you the best value for money, and it will be the one that does the most plates for the least amount of money. So how do detergents actually work? Now what we're going to do is have a look at a detergent molecule, and then we'll focus on how they are able to actually remove and clean any dirt. So we have our detergent molecule here, where we have our chain of hydrocarbon, if you like, where we've got the black carbons and the white hydrogens. Now we then have a charged hydrophilic end. Now you can see here we've got ionization that's occurred. So when we add it into our solvent, such as water, we then remove the sodium atom here, leaving a negatively charged end. Now that charged end is what we call a hydrophilic end. Now hydro means water and philic or phile means loving. So this is water loving end. So this negative charged part is able to attract very easily to water, and that's because water is what we call partially charged. Now this opposite end here is no charge at all. We've got complete covalency in here, meaning that we have no charge like we do at this end. Now this means it's hydrophobic, which means hydro, water, and phobic means phobia, to hate. So how is it able to actually clean? Now we've got an example here of where we've got oil and water. Now we've got our detergent molecule here, which has its hydrophilic end here attached to the water, and then we've got our hydrophobic end, which is attracted to the oil. So we have our water with our detergent in, and then we have our oil that will be stuck to our plate or whatever it is that we're trying to clean. Now because we've got the hydrophobic end attached to the oil, our hydrophilic end attached to the water, when we're able to move it, it will totally surround the oil and remove the oil from the plate. So you've got lots of water around this tiny oil particle, allowing that oil to be removed. Now quite often we will have clothes that require dry cleaning. Now this means that we cannot use water. It may also be because the stains are insoluble in water. Now here are some stains that are insoluble in water but are soluble in other solvents. So pen ink will dissolve in methylated spirits, shoe polish will dissolve in white spirit, and correcting fluid such as Tipex, other brands are available, can dissolve in white spirit or nail varnish remover. So why are these stains removed by this and not by water? Now it's all to do with the intermolecular forces between the solvent, which is the white spirit or nail varnish, and the stain that it's trying to remove. Now when the stain is within the clothes or whatever it is on, they're held together by weak intermolecular forces. Now when they come into contact with the solvent, if the intermolecular forces between the stain, such as the pen ink, and the methylated spirits, the solvent, if it's stronger than it is between the pen and the clothes, then it will be removed. So this means that the solvent can surround the stain and it will be more easily removed. Okay, so that concludes our lesson on detergents and concludes our chemistry topic C6, which is, as I said, our final chemistry topic. Now we've looked at washing powders and washing up liquids, and we've looked at the components within them. We've then looked at the detergent that they both contain in there and how that's able to remove things like oil, which might not necessarily be able to be dissolved into the solvent, which is water. We've looked at the hydrophilic end, so water loving, which means the detergent will attach itself to water at one end, and the hydrophobic end, which will attach to the oil, and then it will pass through and remove the oil. We've then looked at how dry cleaning works, and remembered that the solvent that it's used will have a stronger intermolecular force with the stain, allowing it to surround the stain and remove that stain. Anyway, I hope you've enjoyed this lesson, and I will see you next time. Take care. Bye bye.